Okay, Science Monday. Science. Get your science book out. Open up to page 458. If you're a sibling, share the book. Sit it between you guys. Pay attention to what I'm asking you, what I'm telling you. So my plan is to get through a couple pages each day, and then you guys will have a quiz about what we talked about. Maybe every other day, maybe every day. I don't know. I'm still working this out. Okay, so I am on page 458, lesson 4 of the batteries. Remember, we're doing batteries. And it says, what are electrical circuits? Now, remember, this is what David does for a living. So hopefully I don't botch it that much. Okay, so if you could get a piece of paper out and write down the vocabulary words, that would be great, because that's what's going to be on the quizzes. So you need to pay attention to the vocabulary words. Okay, so I'm going to just start reading. You guys pay attention. What happens when you turn on a light switch in your room? Where does the power come from? How does the electric current flow? An electric current flows only when it can follow a complete path back to the starting point. So it has to keep going until it can come back. Such a path is called a circuit. When you depend on electronic circuits all the time in your everyday life, how can a circuit turn on a light on and off? An electrical circuit consists of a complete pathway connecting a conductor to a power source and then passing that through the object that needs the current to operate. There are 3 main parts of a circuit. So 1, 2, 3. Number 1, the power source, such as a battery or a solar cell or a generator. So you need the light switch from your house, like a power source, a battery, like on a flashlight, a solar cell, that's going to be like solar power, or a generator, like if you lose electricity, you can turn on a generator. Okay, the second thing you need is a load. So the first vocabulary word is load. I would write 1, 2, 3 and write down those 3 points that you need for an electrical pathway also on page 458. So vocabulary word is load. I'm also going to put 1, 2, 3 on my notes. Okay, so a load or electrical device uses current such as a light bulb or a motor. So it's an electrical device that uses current. Electrical device that uses current. Okay. Number 3, a conductor or a wire that connects these parts together. So you need it to connect the power source to the load. So you need the wire that connects it. Okay. So that's 1, 2, 3. Many electrical circuits have a 4th part, which is a switch that opens or closes the circuit. So you need something to turn it on and off. Some things run all the time, like your heart runs all the time. But anyways, but most electronic things, they have the opportunity to turn them on and off. The load. Okay, so here we go. We got a closed circuit. So the second vocabulary word is a closed circuit. Closed circuit. Okay. In a closed circuit, electrons flow from one pole to the power source or to the other in a continuous path. So electrons flow from pole to power source. Okay? In an open circuit, so now we have open circuit. Open circuit. Okay. This happens when the switch is open and there is a break in the circuit. So this is when the switch is open. Switch is open. And then there's a break. With a break. Okay? Because the path is incomplete, the electrons cannot flow. So when it's open, it stops it. When it's closed, it's continuously running. Okay, why do some circuits have switches while others don't? Well, you don't always need a switch to run things, right? But it is nice to have a switch to turn things off to conserve energy. Okay, so I'm moving on to page 459. A flashlight is a good example of a basic electric circuit. It has batteries as a power source, a switch to open and close the circuit, a bulb as the load, and a metal spring that metal springs and strips that act as conductors between parts. Can you take away any of these parts and still have a working flashlight? No, you can't, because you need all of them to work together to create that the closed circuit. Okay. So now we're on series circuits. So my goal is to just finish this page today and then we'll be done. Okay, there are two different ways of designing circuits. Both require a complete path. In the first design, all three parts, the power source, the loads, and any switches are connected in a line. When the electric current flows in a single path, the circuit is a series circuit. So our next vocabulary word is a series circuit. So these vocabulary words are what I'm going to put on the quiz for you. So you guys need to be able to know what they are. Now again, you get an open book test so you can go back and look. I will, at the end of lesson 4, you're going to have to take a picture of your notes and hand it in so I can still give you credit for your notes, right? So make sure that you're taking notes with me. That's going to be the easiest way. So on a series circuit. So that's when current flows in a single path. So flows in single path. Okay. The picture shows a circuit. So that's like it's going to continuously flow in the same circle because it doesn't have an on-off. Look at this picture on 459. When do you think that this is going to stop flowing? Look at the picture. So it goes up, light bulb, down, electrical wire, through the battery, up the switch, and then you keep going around and around. When would this circuit stop flowing? It's going to be when that switch opens up and it's not connected anymore. So that's going to break it and open the circuit up so that it's not flowing. Once it's closed again, the closed circuit, it's going to keep flowing again and again. Okay. With the two light bulbs connected in a series, the charge passes through each light bulb. If you unscrew one of the light bulbs or disconnect one end of the battery, the circuit will be broken. The entire circuit goes out because the circuit is open. Where have you seen a single burned out light bulb to make another light bulb not work? Have you guys ever had to deal with Christmas lights and half the string doesn't work? That's because one of the light bulbs on that half of the circuit is burnt out. Now to figure out which one takes a long time, but some people can figure it out if you sit there long enough. Okay, when the light bulbs are added to the series circuit, the resistance goes up. For this reason, the term resistance is often used as a synonym for load. Each bulb in the circuit shares the available energy. This means that if you add more bulbs to the circuit, the overall current is reduced. The bulbs will decrease in the brightness. You must add voltage to the circuit for the light bulbs to shine equally bright. So they're saying the more light bulbs you add on, the less energy that goes through the light bulbs. So like a strand of Christmas lights that's plugged in by itself will be brighter than if you daisy chain them off each other. It's going to dim them a little bit. Not a lot, because Christmas lights don't require a lot of energy. But the more you add to that daisy chain, the less energy that each light bulb is getting. So if you want a really bright light, you only plug one in. Does that make sense? Because you're putting all the energy to one light versus spreading it out from each light. Okay, so tomorrow we're going to talk about parallel circuits. That's where we add a parallel wire in the middle. But we'll see you guys tomorrow. Bye.